So I'm from HP Networking and part of the Aruba team. My team, Sruthik, is also here. So we're going to talk about an interesting topic. I mean, we're just sandwiched between Wi-Fi and AI and all of it. So today we're going to talk about grounding LLMs with Wi-Fi graph rack, and the PCAP logic. I think there's a lot of talk about how to use PCAP in a traditional world, and especially with Wi-Fi. I think we're going to spend more time on it. So basically, all of us know, I think the elephant in the room today is LLMs. The frontier models are there, but we all know that the frontier models are going to go, going to hallucinate. They're going to not give you the right, guidance. They are actually very confident. So if you give them, a certain set of instructions or prompts, I think they're very confident giving you inferences and a lot of suggestions, but they're going to take you to a rabbit hole. And most times, when they will not get the right answer or the right outcomes. So what we are trying to do is, the reality is that in a Wi-Fi network, it's just too complicated. And you have noise, you have radio inference, you have channel utilization. There's so much, situational, or rather, it's more probabilistic and heuristic nature, which I don't think our LLMs are ready to solve those problems yet. I think, as you rightly said, a text prompt cannot really translate a typical RF problem. It is not possible today, and I don't see the frontier models going to solve that anytime soon. These are the models are something that the real world cannot see. I mean, they are not seeing the packets really, so they are just seeing all the standards. They are seeing the the specs and all that, but they're not seeing the actual problems that we have been talking about since morning. And this, I mean, the second issue is obviously the dynamic roaming, right? I mean, that's been the nature of the problem. Roaming happens, instantaneously. You have seen a situation 50 seconds. I mean, a few seconds back, and now LLM has to correlate all of that and give you a very reasonable outcome. And all of this comes down to the hallucinated fixes, right? I mean, it gives you some config change or config knob. I think Rasika clearly mentioned about the complexity of having different deployments. So what I think the outcome of all of this is, we are coming up with a two-brain approach, something like your sort of your gray matter and the white matter, where the idea is you have to build a Wi-Fi rack solution, which we call the plexus, and then the second brain approach is sort of the inference solution that we want to bring to agentic. So what I'll do is, given the landscape of things that we are seeing, we have come up with this as a problem statement where we are not able to identify different set of Wi-Fi problems. We are dealing with roaming problems. We are dealing with, as I said, the DFS problems, intercompatibility issues, the security intercompatibility issues. So bunch of issues that we have already seen, the LLMs are hallucinating. So we came up with this. I mean, this is a solution that we have kind of working towards. So I'll have my team walk through this and a little more in detail.
Yeah, thanks for that, Srihari. Good afternoon, team. So, as Srihari clearly have mentioned, what are the problems with LLMs on the complexity of Wi-Fi we have on networks today, and in general in networking. So, how do we fix this issue? So, the fix is not to wait for a more bigger LLM or a more powerful next generation of LLM to come so that we can solve it later. It can we can't wait for that. Even if with the powerful LLMs, it always can't be expert in everything, right? The problem with the foundation models is that they are too broadly can handle a lot of things, but they can't have the expertise or depth in specific domains like Wi-Fi. So how do we do this? We have proposed a two-brain approach. We call it. One is Wi-Fi graph rack solution. So we have to solve it as two parts. One is what the model knows and what it can prove to actually go and solve that issue. So when a query comes, we have to, it will hit the first brain or first part of the solution, where the model will be grounded to what it knows based on the actual standards and the constraints. Then this constrained context will then have to be passed to a brain to a evidence engine, which can prove that the fault is on the wire to solve the issue with the evidence. So let's look under the hood how this exactly two brains operate. Yeah, so this is the first part, the grounding the theory part. So we just can't fit in all the context that is required for the model in a prompt. We can't just stuff in PDFs because the models themselves have the context window constraint. And so this is the problem, right? You can't give away all the information required to a model. So the standard approach in field to solve this is using RAG. There is a solution of retrieval augment generation, which is semantic embedding of the relevant context, which can be fetched on demand. But even RAG for some of the complicated use cases where you really need to understand the concepts, not just retrieve A, B, C as additional sentences, but you really need to know what's how they are related, how things are have to work and things like that. RAG has a constraint because in a RAG solution, you have to first know what you have to search for. That's a primary fundamental limitation on RAG. Once you know what to search for, then you can search the relevant or related context. But in this case, we need much more than that, right? We just don't want the references. We want the model to have the understanding. So for that, there is a solution or a framework that Microsoft have actually introduced called Graph RAG, where you have a RAG system built on top of a graph database. So all the semantic embeddings will actually be as a part of the graphical nodes, and they will have relationships between them. So each of the concepts and the actual data will be related to each other, and there will be a semantic correlation between those. So with this such a framework, what we can do is we are able to build a use it and build a .11 standards into the graphs and nodes, .11 standards and the vendor specific information and the generic Wi-Fi concepts in themselves into the nodes and edges. With this, since it's a strict graphical representation of data, right? So the model cannot just cite something without quote something without citing it back on the graph. So everything will be related on the graph, and unless the graph strictly asserts the data to trace back and see where in which area where it is related, why something is connected, the graph the model cannot hallucinate any information with this. And because it's a graph, these constraints have to be rigidly enforced. For example, a simple example would be, let's say there is a WPA3 that will require PMF, right? That's a simple relationship between them. And similarly, .11 or FT would need things like MAD and then some PMK1, some other requirements. So all these two parameters will be in you can see the representation, and some of these are how these are related. So once we have the knowledge sources, this will be ingested to form this knowledge graph. So this part of solution, we call it plexus, which means integrated set of network. So some of you can see the edges, and some of those are examples on how they are related. So which configures which relates to what, which may trigger what, and which will depend on what, and which will be subject to what, and which will be generated in which cases, and things like that. So with this kind of reasoning knowledge base, it can then go from really a hypothesis to a really reasoning kind of information or data. And that's how it works. Yeah. Yeah, but we all know, right? Just theory is just one part of solution. Just because we can theoretically know something that won't be accepted as a solution. Now, a chatbot cannot go to a customer and say, "Hey, with my knowledge, I'm thinking you might be facing this issue, so change your Wi-Fi to this channel." That cannot be backed up. So we need a second part of the solution where, with this knowledge, you can actually go and prove in the field that what is happening and why something happened, or some backup to say what's the solution. So for example, let's say there's a recent code 15, right? A recent code 15 would mean a DAuth and the authentication has timed out. That's a theory and the knowledge part that graph can, with the graph RAG, the model can gain. But still, did it actually happen within this timeline? And in which AP did it happen? If there are multiple APs are going on, and was actually PMF, was negotiated, or was it just assumed, and things like that. Unless you can prove this, it cannot be accepted as a solution. So to prove anything on network, we know, right? We obviously need the packets. Those are the only form of representation in network and Wi-Fi where you see what's actually going on in the AP, in the client, in the air, and things like that. So we need the packets for that. So this is the second brain, an agentic RCA engine, which will We call a solution on the LLM world of agentic loops, which is using the reasoning models which can reason over a certain set of given context. It will iterate in this loop. Basically, it will have a plan phase where it can decompose the problem into an understanding of its own concept based on the graph rag. Now we just have seen from the first phase. So it will decompose the given context from the user in a query into a form that it can understand what's the relevant information that it has in the given system. Then it will go to a second phase where it can translate that into something it can use to further debug. So in this case, for PCAPs, we know the standard tool to go about using PCAPs is Wireshark. Everybody in the industry has been using it for years to actually see the packets and then see what's happening in the network, and then maybe use that to debug and prove what's happening. So in this case, how Wireshark will fit in this solution is we have a provide the model skills of Wireshark, which will with which it can dynamically come up with the queries that it can use on Wireshark to go and actually translate that packets and then see the context of the packets. From the plan, it will know what it has to search for. Then with the data, it will go and write the dynamic Wireshark filters to get the relevant data. And then with the data, it will go into the execution phase where it actually executes those filters. It will, once it has the figure out the filters. Now we know LLM, all the agentic solutions have the capability of using tools. You can provide it tools in many forms. There are MCP servers. You can give it as a CLI, or you can give it as a API call. So in such forms, if you provide it tools, it can go and execute them. And using the reasoning, it can also then reason and read the results and then decide. So how this loop will work is it will keep on executing until it can narrow down to a root cause. So first it will come up with one sort of solution. It will figure out the relevant Wireshark filters for that. It will go and execute that filters on that PCAP. It will see what's the output of it can arrive from that PCAP, and then it will reason. Okay, is this evidence enough to prove what it really have to support its hypothesis and what it thought? If not, it will go to the loop again with the output from the first loop. It can provide that as an enriched context, and it will again tell you, it gives you the final result, or it can nail down to something. It can keep on executing. Yeah. So when we say Wireshark and how that would be fit into the solution is the skills in action. So skills has become, I think, even in the previous presentation, somebody has talked about it. Skills has become a very standard way to make LLMs go and use some other form of existing solutions. So a skill will be a set of instructions, a packageable set of instructions and resources and scripts that will enable the LLM to actually use another existing solution. In this case, it will be a Wireshark. So we can see a skill will be, in this case, a composable set of filters based on the .11 fields. So if it wants to do a DR scan, it will know which type or subtype to use filter on, and to how to get a EUPL trace, then how to get specific reason codes and things like that. So we can see that actually translating to into an actual CLI command on the form of Wireshark, which is tshark. So it can go and execute filters like if it suspects a FT failure, right? It can go and first do authentication scan to get all the authentication frames and see why exactly the last authentication frame failed, and it can see if it's a EAPL timeout, and it can see if it's what algorithm was used in that. So it can see based on fixed auth algorithm equal to 2, which is IFT algorithm in this case, and then it can filter out the relevant fields and it can get the status code. So if it gets status code 53, so then it can decide that's an invalid FTA that is happening on the network. Yeah, so we can see one use case with the solution end-to-end in the full loop. So we can see, let's say there is a symptom, and this is one of the most common problems we actually also received from customers in Aruba on the AP domain, roaming failures. So where there is a system with multiple APs, and let's say a client moves from an AP1 to AP2. In this case, the client is not connecting to AP2, or when there is a roaming, there is a failure from the client. So the report that it typically happens is the customer will just say, hey, when I was roaming from this site from here to here, I'm facing roaming failures, and that will be a the initial context that traditionally will be given to a tag, and that person, as a support person, has to then gain the relevant context and then see what kind of deployment it is, and see what's the client that the customer is using, and get the more relevant data, and then have that into the system, and then go about debugging it. So this in an agentic system will be similar, where we will get a intent or a symptom what the user is experiencing, and now with that intent, it has to fetch in the relevant context whatever is available in the system. So that can either happen through maybe questioning back to the customer. In, let's say we have a form of chatbot, right? That you can interface with a LLM. You can ask back for more context to see, yeah, what's the client you are using, or what other information you can provide around your topology and things like that. Now, with other solutions, right, networking solutions on cloud, like for example, our HP Aruba Central or Mist, you can get all these context directly already available on cloud. So if we can integrate LLM into such systems, it doesn't even have to go back and ask customers. It can just pull the relevant information before getting into an executable task. So once that is there, now based on the solutions we see, it can use a theory graph rack. So if it's a Wi-Fi solution, it's not just for Wi-Fi, right? Even if it's a switching, that would require its own set of knowledge, or its own set of rules and standards that it has to first know. So for that part, can use the related theoretical graph rack to find the relevant context, and it will get the relevant information. So in this case, it will be a roaming. So it will have to pull what are the standards, .11 or standards that are related to roaming, and what are the constraints around them, and each of the what are the parameters that are involved. So once it has those, it can, so for example, it will know .11 or FT would need a MDAE and the BMK R1 key. Then it will have to see translate that using the skills into Issac filters to see if that actually happened in that network for that client with the use of a PCAP. And once it has, it can then go and see the frames, actual frames, and then the evidence will catch the DAuth with the recent status 15 at the roaming. So it can literally translate the journey that the client had. So it will, in the initial set of packets, it can see initially in which AP it was, then to which AP it got moved, and finally during that transition, it can see that FT algorithm was used in the authentication phase. And finally, at the end of the roaming, the authentication failed. And it can also see the intermediary state, like the client falling back to open auth, and that's also failing. So with all this information now, during this reasoning loop, it can just get us evidential information it can use to decide on. So once this agentic loop is complete, then it can go and actually root cause that saying AP2 was missing a FT key in the context. So that is an infrastructure failure that was happening. So this is the reason that is roaming failures are occurring. If we can have the system integrated into again like a self-drive solution like Aruba Central or Mist, then you can even go one step ahead and fix that automatically, saying maybe resync that AP to the infrastructure so properly the roaming issue doesn't happen again. So we have the solution already deployed in a form of it's in a beta state. I would say you can try it out. Plexus is available online, where we have two phases: knowledge chat and the incident RCA. So the knowledge chat is like just a chatbot part, where it is backed by the graph RAG we saw. So it can still answer questions around Wi-Fi with more expertise than normal LLM would actually tell you. And it will actually cite to you back from which data source it is able to tell you what is the answer and things like that. So the other phase is this incident RCA, so root cause analysis, where we can provide a issue description and you can provide context around it, like what's the deployment you are in, what's the API generation you are using and things like that. And you can attach a PCAP file that you have collected from the scenario. So we'll see the one use case we have tried it out, just what we saw on the previous presentation, previous slide, is that the roaming use case. So we took an actual roaming PCAP and then used this. So we can see the root causes it is actually able to derive with it. It most likely told the roaming failure is due to the broken .11 or FT key hierarchy between the original API and the target API. So this was using Claude Sonnet model, which was backed by our solution of GraphRag plus this agentic brain. And it can also cite why this is most likely. So this the second part you're saying, right? That comes from the GraphRag of its knowledge. It's telling the FT authentication failure happened and what that means. And the fallback it observed as a secondary point to support that. So it's able to narrow down to a root cause, and even it will provide you the Wireshark workflow that's exactly needed so that we can manually go and reproduce this, what reasoning it did to arrive at that solution. Yeah. So with this, so what I would like to leave you with this is what it takes to trust a LLM in Wi-Fi, right? I say we would not need to wait for a complex LLM or a domain-specific expert LLM. We just have to provide it the right knowledge base to with the constraints so that it can answer properly with citations, and the system to reproducibly claim and evidently prove the problems so that we can also reproduce that and see for ourselves the issue. So yeah, demand citations and demand reproducible commands. And there is a link to the plexus in the screen, which I would like for all of you to try it out and then give some feedback. Yeah, with that, I'll leave it. Thank you, team.
Thank you.
Thank you. I think this sets the stage for your panel discussion also in the afternoon. So anyway, we have time for a couple of questions before Sudarshan comes. There's a mic there. Sudarshan, you are mic'd up. If you want to ask question, you can ask. Yes.
Yeah,
Thanks, Tim. So basically, when I used to troubleshoot, like from the analytics, I mean, whatever the things that you have discussed is through like analytics of finding the RCA. So you think like if we have a lightweight agent installed in the device itself, like it will be helpful more than like what you are like collecting from the access point or the controller, because most of the time like we go and ask the users like what was the experience. Instead, like if we have any agent installed in the device, so just collect it and see what happened during that specific time, and it will be easy for troubleshooting, right?
Yeah, I'll take that. So you have a very valid point. So I mean, the biggest challenge with that is we don't know the efficacy of some of those problems. The agent on the device or closer to the device is actually the way to go. I mean, that's what I know some of us are been discussing. But the problem is how efficient, how efficacy that will solve all the problems is something that we are yet to achieve. As of now, a cloud, a combination of device plus cloud is the way to go, because you have the data set on the cloud, larger data set of the cloud, across deployments, across customers. So you will be able to give a very good set of metrics that, I think the idea of human in the loop can happen being on the cloud. On the device, I don't think that's possible. So agent is still, I would say it's still on the device is still far ahead. But it's possible, but still far ahead, because we have to understand the efficacy.
Thank you.
Yes.
One more question, if you have, please put up your hand.
Mentioned, the efficacy aspects and the access to the larger data sets across many customers within the cloud. My question is, why should that be relevant? Because you lose context when you go across customer bases. Isn't that going to make your inferencing worse?
Not necessarily, but we have seen some thresholds. So basically, what we have done is we have done some baselines, beyond which metrics this inferencing is going to go above or below. So having data sets across customers give us that threshold value because what we have seen is the deployments are completely dynamic, very dynamic in nature, and that dynamism, I'm not sure if we're able to do it on the device. So when we get on the cloud, we're able to see the bigger picture. That variation is what we are able to gauge, and then we are able to act on it. That was not possible staying on the device.
Yeah, and to add to that, one more metric is on cloud, you have the data on the past also, right? Past device can only give you the data at the point of time.
My question was in the limited context of on cloud, you have access to many other customers' data. Right? Why should my data not be the one that is dictating my experience? Is sort of the angle I was trying to get at. Why should, because the environments in other places may be so very different, you cannot capture all of that.
But we are always learning from other data sets, and we want to infer from those data sets into the current problem.
My context is even in your specific network, it's in device, it's not possible to store the time period kind of time series data, right? In cloud, one of the advantages we have is we will be able to see your past data as well, and then we can do some analysis based on broader context.
I think since I've given one quick question, yes.
Yeah, okay. Yeah, so this is like basically a field technician can be someone just if there is any issue on the field, just you will ask him and go and capture the PCAP and just upload in your cloud and you will get the data? Or is it like this is a prefix of what a self-healing is supposed to do based on the data that is being fed?
That's the eventual goal. But as of now, it's a post thing. It's a day two thing. You have deployed, somebody reports a problem to you, and we have seen issues taking up to 6 months to get resolved because they just don't know where to solve. So now we are bringing that back into the system, saying, you have so much data, we have this inference. Now you just respond back to the customer saying you just manipulate this. What we are seeing overall is this will, as somebody is asking, some part of this will eventually come onto the device. That's what we are saying, and that will be a very small LLM. Yeah.
Yeah, thanks. I hope you will stay back for the panel discussion where there will be some AI related.
Yeah.
So thanks once again. Please give them a hand.